Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Get started for free with a $100 credit. Head to do.co/changelog. Again, do.co/changelog. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Gopher Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello, I'm Matt Ryer, and guess what? It's only go time. Today, we are preparing ourselves for the robotic uprising, and spoiler alert, it's going to be adorable. Today, we're talking about TinyGo and Gopherbot, and I'm joined by the creator of Gopherbot, and I've heard him called the Santa of open source. It's Dead Program, aka Ron Evans. Hi, Ron. How are you?
Hey, everybody. Actually, it's TinyGo time today.
It's TinyGo time. Yes. Do you prefer Ron or Dead?
Well, I'm not dead yet, but...
So we'll go with Ron.
Yeah, Ron is good. Ron is good. I prefer Dead Program in its entirety, kind of like Prince. You don't call him Pri. You just call him Prince.
Yeah, Dead Program. It could just be like a crash symbol or something. But yeah, well, welcome to the show.
Only if I have to do that due to a kind of disagreement with my record label.
Which I can see happening, frankly, Ron.
It's possible. It's possible.
Cool. Yeah, so this is actually the first time we've done a show like this. It's going to be a very intimate show. So, get close up to the microphone and it's all snuggle. It's just going to be me and Ron today talking about this. And
the robots, of course. Just me and you and a bunch of robots.
Yes, and we're going to learn a little bit more about those cheeky little robots, starting probably with TinyGo, because I think that's really where it starts, where Go's part of this starts, doesn't it?
Yes, well, I've been on Go Time before talking about some of the other stuff that I've been involved with in Go and robots and drones and computer vision. GoBot being the best known of those. And then last year I was talking about GoCV, which is computer vision using Go and OpenCV. But what I've always dreamed of, and what I've wanted since the very beginning, was the ability to run Go on the tiniest of chips, known as microcontrollers. And these are the little tiny chips that are in everything, like keyboards and mice, brake systems, the small chips that connect up to the physical world and cause all the things to happen or not happen at the right times, hopefully, if everything goes well. But we've never been able to run Go on those small chips because they're so small. And Go is a great language. It's very powerful. It does all these amazing things, but Go is not known for being a small. But the number of keywords is small and the binaries are large. Let's just put it that way.
Yes. So Go was too big for those microcontrollers then?
Yes, by orders of magnitude, in fact. So, hello world in Go, when you compile it for a Linux operating system, is about 1.1 megabytes. And to be fair, it includes the entire Go runtime. So, it's got everything that you're ever going to need to a large extent. A program that does nothing more than output hello world, and a program that does some fairly sophisticated processing are not going to be that different in size from each other once you hit that basic, initial baseline. But when we're talking about, microcontrollers, we could be talking about processors that have 64K of RAM to the entire processor, or even less. So I've wanted this for a long time, but it's never really been possible. And people are like, dead program, you're crazy. It's never going to be done. But there were a few people who tried and did some really cool stuff. There's a project called MGO, which basically took Go and transliterated it into C code that you could then compile with the GCC compiler for different ARM-based embedded devices. So that was sort of a step in the right direction, but it wasn't real Go code. But a very cool project and a lot of amazing work done by its main creator. But it still wasn't getting me there. And talked to a few other people trying to convince everyone who I thought could actually do something about this problem of, how can we take and compile a Go down to something that's so small? And it wasn't until last year, about, I think, September timeframe, that I became aware of this TinyGo project, which was originally started by my main collaborator, Ike van Latem. So he is a contributor to a number of projects in the embedded space, in particular MicroPython, which is a version of Python that runs on microcontrollers. And his attitude was, if Python can run on microcontrollers, and if JavaScript can run on microcontrollers, why can't Go, right? But his take on it was really unique and especially powerful. So Go, it turns out, is actually written in Go, right? The Go compiler is written in Go.
It didn't used to be, did it?
No, originally it was written in C.
Why didn't they use Go then?
So you had to compile Go using a C compiler like GCC, and then once you had your Go compiler compiled, then you could compile your Go programs. And so up until, I can't remember exactly which version, maybe 1.5 or something like that.
I think so, yeah.
I can't remember the exact version, but you had to do some real work in order to compile the Go compiler itself. But eventually came a time when the Go compiler was written entirely in Go. So that's really, really useful for the Go core team and also for anyone who wants to contribute to the Go compiler itself, because you could read the compiler code if you can read Go.
Mm-hmm.
And that's been a problem, by the way, for some other really cool open source languages like Ruby or Node.js, where people said, I want to contribute to this. And they're like, yeah, but it's not written in JavaScript. It's written in C++. And I don't know C++. So sorry, I can't contribute, really. So, Go being written in Go, it does definitely lower the bar, but it also creates new possibilities. So because Go can parse its own language in Go, you could use Go's own libraries and tools to then take the Go, what's known as the single static assignment, which is when you take the Go text of the Go language and the Go compiler is going to take that and turn it into machine code, it takes it and it parses it, breaks it apart, and turns it into this SSA form before then the rest of the Go compiler tool chain turns it into the binary language.
Sure.
So Ike said, if I take this SSA form, I can then put that through the LLVM tool chain and create my binary code using that. So LLVM is a set of compiler libraries and tools that is been around for quite a while. I'm not sure how long. I've known of it for at least 12 years, but it's probably been around for longer than that. And it's become very well known because there's some languages that a bunch of people are really interested in that are using LLVM. One of them is Swift. Swift is an LLVM compiler toolchain language. Another one is Rust. Ike took the SSA form created by the Go compiler toolchain, and then TinyGo, this compiler project, then takes that and turns it into the LLVM intermediate representation so it can then be compiled for whatever targets are supported by LLVM. So some of those are microcontrollers, like the Arduino, which uses the AVR microcontroller. All of the ARM-based microcontrollers, like the Circuit Playground Express from Adafruit, which is a really, really cool microcontroller. All of the new Arduinos are based on these types of ARM microcontrollers, like the Arduino Zero and the Maker 1000. So there's a lot of, pretty much most of the interesting, small, inexpensive chips are based on these types of microcontroller architectures. And if we can compile this code down, so in February of this last February, I presented the first talk about TinyGo at FOSDEM in Brussels. And it was really, really exciting. Ike was there. He came in from the Netherlands, which is where he's from, and some of the other contributors from other places. So we also had the first Birds of a Feather session right after my talk, but the organizers of FOSDEM were kind enough to put the talk into the main room. So I actually gave the first main room talk ever about Go at FOSDEM. That was kind of amazing. Like, I think you guys should have picked one of the real Go people first, but like, hey, TinyGo, let's do this. But it was really exciting to get to, share the results. And we had the first release of the software. But the demo I showed a bunch of demos, but the one that really got a lot of people's attention was I compiled a TinyGo program that was 500 bytes in size that ran on an 8-bit microcontroller called the AT-Tiny85 that has only 8K of RAM.
Oh, wow.
Okay. So I can compile a Go program for an 8-bit microcontroller that has 8K of RAM.
So that is tiny.
That is tiny. I picked it basically because the name of the microcontroller had tiny in it. I'll admit.
Yeah. So then the Go source code gets turned into this SSA, and then the TinyGo kind of tool chain takes it from there and creates these tiny things. But so what's the trade-off then? What do you lose? What's not in that 11K hello world that is in the 1.1 megabyte?
Well, that's really the trick, is we're not able to take 100% compression is 0% information, I believe, by definition.
Right. Yep.
It's not the full everything that's in Go. One of the big differences is the runtime is different when you're running on a bare metal, with no operating system. So we have to implement the runtime calls differently. Another challenge is the standard library of Go. A lot of the standard library we can compile, but a bunch of it we can't because it's very tightly coupled to the runtime itself.
Yeah.
So in those cases, we have to implement, a slightly more operating system agnostic version of some of the runtime or some of the standard library. So there are some trade-offs involved, and, we're not able to compile all Go code yet, nor is that really the primary objective of what we're trying to do. The Go core team is doing really great work. We're not trying to replace Go is bad, TinyGo is good. No, nothing like that. Quite the opposite. Really, we're saying, wow, Go is such a cool language. There's places where we'd like to execute Go code. Can we come up with another implementation of the Go runtime and standard library while still keeping the same Go programming language? And for that matter, how much of the same standard library can we still continue to use? Maybe all of it, maybe most of it, certainly much of it. And so, there are trade-offs because of the environments in which it needs to execute. But one of the big benefits is we're not bringing along all of the extra things. I mean, no one's using the entire standard library all at once. I mean, if you are, wow, that's one heck of a piece of code you got going there, friends,
Well, you certainly wouldn't want to run whatever that was on tiny edge sort of hardware, probably. But some things are obvious, like the OS opening files and things like that might be different in a situation where you don't have much of a file system. I don't know if that's a good example. But what about...
That's actually a great example. On a microcontroller, you don't have a file system at all, right? But you could. We don't actually have this implemented yet, but it's on our roadmap. So there's a lot of small devices that will typically have either flash memory or an SD card interface. So those devices will typically use the SPI or SPI interface, which is a low-level hardware interface where the microcontroller can then talk to that. So that device could have a file system on it. Very commonly, FAT is the file system kind of default of a lot of these devices. So when you get an Adafruit Circuit Playground Express, it has a 1 megabyte flash drive built on to the board itself that you can use for storing different kinds of data files that you might want to read from your microcontroller code. Eventually, we don't have support for this yet in TinyGo, but it's on our roadmap. You could have, for example, WAV files, which you then play back using the digital to audio or analog converter, the DAC, that's also built on. So you could play back, WAV files as a part of some of the interesting interactions. Or you could record data remotely, devices that are either not cloud connected all the time or are not meant to be. For, you would maybe still want to be able to save data.
Right.
Maybe you want to train your device to recognize your voice, but you don't want to actually put any of that data on the cloud. You're going to need some type of local storage. So these are, low-level interfaces to things that you need to implement. Some people are doing that using things that are called real-time operating systems, which are, it's not a full operating system, but it maybe has some of the capabilities, some of the memory allocation capabilities and some of the file reading and writing, some network capabilities. But we're really trying to use the Go standard library wherever we can.
So in that example, would TinyGo have to have its own OS package that you write that just does completely different things, but maybe copies the interface of the standard library's OS package? Is that how you would address it?
That is actually what we are doing in several cases. One example is we've been working on adding Mac OS support. And so, to implement that in sort of an agnostic way. But even better example is the bare metal, where we need to be able to say, there's no, operating system primitives at all. So we have to either implement them ourselves or leave them unimplemented in some fashion. We have a wiki page on the TinyGo repository where we talk about kind of the main challenges we have with how Go itself is currently implemented. And that's one of them is sort of this tight coupling between the runtime and the standard library. And there's actually been some really good talks that were done. I was at one of them talking about design of Go 2. It was Ian Lance Taylor did the talk talking about the Go 2 transition. He's actually done a few talks about this. I caught the first one at Gopherpalooza, I believe, in San Francisco. Actually, really cool conference that took place last year. But talking about how the runtime and the standard library are a little too coupled, and some proposals for decoupling that. That way, if you implement the runtime correctly, then all, ideally, of the standard library would still continue to work. So, for TinyGo, this is a real challenge technically, but we're able to get around this by sort of re-implementing some of the primitives in ways that are logical in the context of you're running on something that has very little memory. And there's also some other important differences, which is, how microcontrollers really work. Well, on microcontrollers, you have registers. And these registers are typically used for very low-level hardware-based communication. It could be turning on and off LEDs using the GPIO kind of interfaces. Or it could be communicating with other chips that are connected directly to the microcontroller, like the SPI interface in our little flash example, or the I2C or I2C interface, which is what's used by a lot of sensors like digital compasses, magnetometers, more officially, accelerometers, which are motion detectors, thermometers. There's a lot of different sensors that use these I2C type of interfaces. So one of the most important things that we've been doing with TinyGo is creating drivers, which provide sort of standard interfaces, again, defined in Go interfaces, so that you can write some code that if it uses the same, LIS 3DH digital accelerometer that's in the Circuit Playground Express board, that same code could be ported. There's a cool new, there's a project that's on Hacker News and a bunch of websites about a homebrew smartwatch. I don't know if you guys saw that today, but that uses the same digital accelerometer. So, we could potentially, I haven't gotten that hardware and haven't looked that close, but if it's one of the processors that TinyGo supports, we could, theoretically run TinyGo on this watch and then connect to the same sensor that it's already got, without changing the code too very much, if at all.
Oh, that's awesome.
Yeah, this kind of hardware abstraction layer is really important because you don't exactly always know what kind of target hardware you're going to want. So we can sort of decouple the drivers that know how to do standard functionalities of reading the temperature or detecting the accelerator's motion from whichever chip it's running on, whether that's one that's coming from Microchip or Nordic Semiconductor or NXP or Intel or whoever. And, by doing this, that's in the spirit of what Go is doing as far as it's, trying to be operating system and architecture agnostic.
Yeah.
We're just extending that into Go, OS, no operating system, would sort of be our ideal use case.
Yeah, you mentioned interfaces there. Does that mean that that would be a place where you could potentially write unit tests? If you're dealing with an interface in Go, is that an opportunity where you could write code that wouldn't have to have the physical hardware? You could just test it against this interface?
Yes, that's absolutely the case. And a few things on that. Well, first of all, testing. Absolutely essential in any modern software development.
No doubt.
And yet, here we are, it's the 21st century, and most embedded software is using sort of ad hoc style manual functional testing, primarily. The joke goes something like, hey, I just looked at this program, it's 10,000 lines of code, no tests. What? Unacceptable. Oh, well, it's an embedded program. Oh, okay, never mind, ship it.
Oh, no.
Don't worry, it's only in like a jet airplane or maybe like a laser that's used for brain surgery or nothing too important, probably.
Yeah.
We don't actually know. We just sell these chips to someone who sells some boards to some people who then use them for something.
Yeah, exactly, yeah. Not their problem,
Hope it all works out, So this is not an acceptable way to approach software development. So by trying to tie into, first of all, as you said, we can use interfaces so that we can test things not necessarily with the physical hardware attached. We do some of that right now using QEMU, which is a software emulator of some hardware. Then there's some other cool projects. There's one from Ant Micro, whose name escapes me right this second, but its specific purpose in life is to provide software emulation of specific microcontrollers. So, there's a lot of things that we can do for comprehensive testing in depth of different embedded systems by using modern languages and modern compilers that really, if we're talking about software reliability, it's just that much more important when we're talking about edge devices where, safety is obviously, one big concern, but also there's, second order effects. I mean, if it gathers information incorrectly, that could cause us to ignore problems. The sprinkler system may not be mission critical, but if it wastes a bunch of water in the long term, that's very bad.
Yeah.
In the short term, it's really bad because you just got a massive water bill. So, these are things that we can do something about by testing. Another is temporal testing, right? So if we want to test our sprinkler system and we want to make sure it works correctly and we have nothing but physical functional testing, then each iteration, we're going to let the thing run for a whole week to make sure it turns on and off at the right times. If we can write some unit tests where we can, test that it actually is triggering the events at the right times, we can accelerate. I mean, this is normal iterative software development with the proper mocking of things, and proper interfaces can lead towards better architectures anyway. if we combine these things together, that's really our only hope of writing the kind of software that we need to be for, touching the physical world.
Yeah.
The last millimeter.
Yeah, touching the physical world is a great point at which I can now talk about our great giveaway that we're going to do today. So what we're asking people to do is either review the podcast positively, ideally, socialize share it, tell your friends about it, about the podcast, in particular this episode. So once this is in the podcast, if you share this on social media or whatever, or just recommend it to a friend or whatever. And if you want to be entered into the quiz, just take a little screen grab of the thing just to prove it and send it to gotime@changelog.com. The information will be in the show notes, but you will want to check this out because I think the prize is pretty awesome. And Ron, this might be a good time to talk about what that prize is, and we can delve a little bit into that project.
Yeah, so we're going to be giving away a Gopherbot. So what is Gopherbot? Gopherbot is a robotic gopher plushie, which is programmable using TinyGo.
This episode is brought to you by StrongDM. StrongDM makes it easy for DevOps to enforce the controls InfoSec teams require, manage access to any database, server, in any environment. And in this segment, we're talking to Jim Mordko, VP of Engineering at Hearst. He's sharing how they're using StrongDM within their team of 90 plus engineers. It now takes them just 60 seconds to offboard a team member from a data source.
We have an engineering team of somewhere in the area of 80 or 90 engineers. Because we've got so many services and many databases and so many developers, we need a reasonable way to manage access to them. It was a somewhat painful and labor-intensive process. Our DevOps team would literally have to manage every one of the permissions for everybody who wanted access. So StrongDM has been a real godsend in that area for us. Requests for access to specific databases were pretty much manual. Now we've adopted StrongDM. It's something that you don't even know is there. Once it's installed, it just works. It's very simple. We've set up a multitude of data sources so that when somebody's onboarded, we just give them access to StrongDM. It's pretty simple. Our DevOps team, they have a very minimal effort required to enable each data source to be connected to StrongDM, and then installing the client software is it's very, very simple and straightforward. You can use whatever client you want to talk to the database, so there's really no training necessary.
All right, if your team can benefit from nearly instant onboarding and offboarding that's fully SOC 2 compliant, head to strongdm.com to learn more and request a free demo. Again, strongdm.com.
So a bunch of people have these really awesome Gopher plushies that you've gotten over the years at GopherCons and other cool events. And so collaborated with my brother Damon, who is also a hardware hacker, and he designed a 3D helmet that I then installed a bunch of LEDs and sensors and things into, and people really liked it. So we thought, wow, what a great way to help raise money for our open source efforts and at the same time create a really cool, programmable, collectible, robotic plushie toy. So Gopherbot is our expression of that. And so it uses an awesome Gopher plushie from Golang Market combined with a 3D printed custom helmet. So there's 2 different plushie colors, and there's 10 different helmet colors. And I haven't decided on how many different LED colors there are yet. I haven't even told people that they can choose LED colors yet. That's going to be a surprise once the campaign ends. So it's got built into it, it uses an Adafruit Circuit Playground Express microcontroller, which is a really, really cool little circular microcontroller from Adafruit. Awesome company out of New York doing really innovative stuff with hardware and with software as well. So in the helmet, there is RGB LED array that gives you 15 different LEDs, each of which is individually controllable for its RGB colors. We have the blinky LED on the end of a spring, which in fact is springable. You can go boing and it still works.
That's my favorite bit. If you go to gopherbot.com, there's a GIF that I assume you made, Ron, and it shows off the project and it shows the little Gopherbot. And then one of the scenes is just a cutaway of Ron just like dinging the spring on top of his head. It's brilliant. So you should definitely check that out on gopherbot.com.
Yeah, that took the most engineering, was an LED that could be on the end of a springy spring and still continue to flash while going boing.
Yeah, I mean, as far as requirements for a task in software goes, I think that one's got to be up there. You see, I'm really pleased that this happened because when I've seen some talks about TinyGo, and whenever software reaches out into the real world, I get really excited because I was basically a web developer my whole career. So when I heard about TinyGo, I was thinking, how can I play with this? Like, I wish there was a kit that I could put together and start to actually write code and things. And then, of course, Gopherbot comes along, and that's exactly what that is, isn't it?
Exactly. The kit includes the LED helmet, the spring, the circuit board, a backpack to attach it to. Inside that circuit board are a bunch of sensors. There's a light intensity sensor. There is an accelerometer, which can detect motion in X, Y, and Z axes, so it can detect when it's moved around. There is a built-in MEMS, MEMS microphone, which uses the I2S interface for sound recording. There is a digital to analog converter, which is it's got a little tiny speaker. It's got 9 more of those LED controllable NeoPixel LEDs, so you can control the colors on them individually. There's a bunch of videos that we posted on the Instagram for FurryBot, FurrieBot, FurryBot, on Instagram, and we have a bunch of videos showing different. I mean, it looks like it's all filtered, but literally not one of those photos is filtered. They're all taken on my Android phone, just in different positions with. Some of them, there's, poses with a bunch of other famous robots or toys, parts of my collection. I really like toys.
What's the Instagram for that again?
FurryBot, FurrieBot.
I'm surprised that was available. So would you be able to then write TinyGo code and then flash it onto the Gopherbot? Is that the idea? Is that how it works?
That's exactly how it works. You write the code on your computer. You compile it, you transfer the code onto the microcontroller, the little Circuit Playground Express board, and from that point you can disconnect from your computer because all of the code is running right on the little circuit board. So, for example, you want to make a little Tamagotchi-like toy where you take the thing around, or you want to go to a party and you want to be able to have it pulse its visor in time with the music or something and run off batteries. You could do that. I mean, there's no wireless communication capability built in to Gopherbot as it comes, but you could add that very easily. One of the demos I showed at the FOSDEM talk was connecting a ESP8266 Wi-Fi chip to the microcontroller so that it then had Wi-Fi capabilities. But that's not something that we've got built in. One thing that's, I think, people don't necessarily want connected toys, but they do want programmable toys.
Yeah.
Those are two different things. One is sort of, oh, well, hello, Barbie is listening in on you and telling your deepest, innermost thoughts back to our corporate headquarters.
Yeah.
Not necessarily good. The other one is you can program Barbie yourself to do different things. Barbie creators might be like, oh, what if Barbie says something we don't like? Well, that's the trick, isn't it?
Yeah, that's the point.
Programmable toys are going to be used for things that the creators did not imagine. And exactly, that's the whole point. That's what makes them fun.
Yeah, that's right.
We've seen, there was kind of some sad news about Anki. Anki is a really cool robotics startup that was super well funded. They were kind of the darling of Apple's WWDC a few years ago with their Bluetooth controllable race cars. But they announced that the company was folding all of a sudden, and which is too bad, sad news. But one of the problems, I think, with the products they made was they made programmable toys that were not open.
Yeah.
The toys could only do whatever it was that their APIs inherently provided, and you couldn't go any further. So all their software development efforts were on their own teams to achieve.
Mm-hmm.
And furthermore, if you wanted to exceed those capabilities, you either couldn't do it at all or could only do it, similar to what we had to do with the Tello drone at the cost of, a massive amount of reverse engineering. I mean, if it wasn't for 6 of us basically kind of being out of our minds with the Tello thing, like, oh, I got to make it fly, so I'm going to dedicate, hours of my life to writing Lua scripts and things, it wouldn't exist. And is it really in the interest of the toy manufacturer to limit you like this when with a bit more effort, to me, all toys should be programmable. All toys should be hackable. Certainly, if it has programmable capabilities of its own, those should be opened up. If nothing else, that way we can confidently look at it and say, oh, well, actually, no, it's not surveilling us and sending back information to Gopherbot headquarters,
Yeah.
I mean, it is programmable. You could add that capability yourself, but that's not something we're planning on doing.
No, but you're right. And actually, I think that applies to everything. Making things hackable so that people can take it and play with it. That's the fun, isn't it? That's all the fun in it. And we're going to, for toys, I always did anyway, when I was young, after I'd played with the toy for a while, a few months maybe, I would definitely be looking for any screws to take off because I just wanted to know what was going on inside. So we're going to do it anyway. You might as well make that happen.
Yeah, right. I bet. How many of your toys made it 1 hour without something being taken apart? We have to ask your parents to be sure. I would bet that very few of them survived the first couple of days of prying them apart because they weren't meant to be, right? What if they had actually said, yes, this toy can be taken apart and put back together and still continue the work? Wouldn't that be great?
Yes. On the other hand, the opposite is Lego. Lego is rubbish unless you build and hack with it. It's just a bag of bricks otherwise. So yeah.
Exactly. It's a hazardous thing to step on.
It's exactly. And actually, there's only one thing worse than it in our country, which are the plugs, the power socket plugs in the UK. Yeah, they naturally are extremely dangerous. They naturally fall with the spikes up. So it's just that, a lot of us have harsh memories of standing on plugs. So actually, just want to say this, Ron, it's interesting. So Justin Clift on Slack, and by the way, listeners, you can join in if you listen to the live show. You can join in on Gopher Slack or in the hashtag GoTimeFM channel. Justin Clift's in there. He's just been talking about WebAssembly. And actually, somebody tried it, and a 2.5 megabyte Go WebAssembly binary with TinyGo is 575 bytes, apparently, which is pretty good.
So, yeah, we said we weren't trying to take over all of the use cases for Go, and that is true. But there's a few of them that maybe we could do a little tiny bit better. Pun. I could now make Tiny and Go puns, and ideally in the same sentence.
Well, that's amazing.
That's the triple entendre. It's very rarely attempted and only occasionally pulled off. But let's see if I can get there. But yeah, the...
only occasionally pulled off is only a double one.
Yeah, exactly. Well, WebAssembly is extremely interesting. For those of our listeners who are not at all familiar with it, I'd be surprised, but WebAssembly is the new attempt to create a new web runtime where inside of a web browser, the ability for code to access more native capabilities for faster processing of things to make it more efficient, not to replace JavaScript in the web browser really, but to enhance it for a number of reasons, performance being a really important one, certainly in a lot of cases. And so there's a number of languages that are able to compile to this WebAssembly, which is actually an instruction set which is designed to execute inside this sandbox. So LLVM, which is the compiler toolchain, which you may recall from the beginning of this, is the one that TinyGo is using to generate its code. LLVM can generate WebAssembly as its backend. We have a couple of people who are focused on the WebAssembly parts. I know surprisingly little about it. I'm really learning. Justin Clift is working on it. Johan Broadhurst, who gave a really great talk at .go a few weeks back, where he included TinyGo as part of it, is one of our TinyGo team members now, helping to make the web safe for TinyGo. But yeah, going back to Go is awesome, Go is powerful, but Go is too big, and having, a 1 megabyte download to your mobile device is sort of kind of a no starter, especially if we're talking about remote locations where bandwidth is expensive and limited and maybe not even possible, right? So if we could compile Go code, which is intended to be executed inside of places where WebAssembly can be executed, and we could take advantage of the much smaller executable size while still, preserving the things that we like about Go syntactically as well as capabilities. Wow, that's a really huge development for something so very small. So that's a big, important area for TinyGo. Microcontrollers is one, WebAssembly is another.
Yeah.
And then there's two more that I'd like to just briefly mention. So Justin is in there in the Slack channel saying it compresses down to 408 bytes with gzip. So yeah, I know at some point you're like, how small can we get it? Oh, you got to save a couple more bytes just because you can. But also because it's important, right? I mean, we're used to being very consumptive these days. The largesse of our use of technology is incredible. One of the most amazing things I ever saw as a young kid programmer was this thing on a Commodore 64 called GEOS. GEOS was actually a full windowing operating system that ran in 64K of RAM. Absolutely incredible. I met one of the creators of it one time, and I was a total fan. I was like, how you could do that was just incredible. And then I thought about how much waste we're all like throwing around, thinking, oh, well, no big deal. Computing is cheap. Well, computing is not cheap. It's just the costs have been externalized. The cost of generating the power, the cost of cooling it, a lot of those costs are just being sort of shunted off to the environment right now as opposed to actually being paid for by anyone. So, as time moves forward, efficiency in computation is going to be even more important because of utilization of resources on the one hand, and because of our increased desire for computation on the other. We want machine learning algorithms to be able to execute on edge computing devices where they can actually do some good. As cool as the stuff that MachineBox has done, it's not going to help with a drone's collision avoidance algorithm just because we have to execute that, right on the drone itself, or else it's not going to do us much good if we have, a bad Verizon connection that day, right?
Yeah, right.
There's use cases for all these things. It's not either or. That's a false dichotomy, right? Mm-hmm. TinyGo's mission is to say there are places where Go has not yet been able to go, right? And we want Go to be able to go there because any sufficiently mature language has more than one implementation of it, right? Look how many implementations of Python there are. Look how many implementations of C are there. There's a bunch of C compilers. How many C++ are there? How many JavaScripts are there, right? We've only had one Go until TinyGo. I mean, there's a few others that have tried to do this that I've seen, but none have really said, let's use Go itself to write a new kind of Go. That's still Go, but is able to do some things that are important. And then the last big one is the future. The future. The future. We're really in the most exciting time for computing that I've ever seen. No joke. Why? Because we're literally on the first step of a Cambrian explosion of actual custom silicon. So we've talked for years about, wouldn't it be great if you could create chips that were specific to a particular purpose so that you could do certain kinds of processing more efficiently or more cheaply? But there's no practical way to do that. You need to get chip designers that know esoteric knowledge, and you have to pay big licensing fees to companies that provide not just because they make you, because of patents and stuff, but because you can't actually do it without their help. Like, oh, we're going to build a new chip. 10 years later, yeah, we're going to build a new chip. Like, how far did you get? Oh, well, it's really hard to do that. So RISC-V is a technology that some people have heard of and other people have just sort of heard the buzzword. What it really is it's an open source set of silicon designs so that you can build your own custom chips the same way that we've been able to build our own custom operating systems out of pieces of Linux to create our own Linux distros. We'll be able to do the same exact sort of things with custom silicon. So TinyGo is going to be able to run on RISC-V because of using the LLVM backend. And I'm just waiting for my sci-fi prototype board to arrive. So I meant to actually have a demo running of this before I told anyone, but I got really excited because so many people are really doing cool stuff with RISC-V, and here I am waiting for my shipment. I can't take it anymore. I have to talk about it. But if you think about what that means as far as the new possibilities for creating custom chips for solving problems that were, too expensive to solve because we're going to need too many sensors to do it, or too difficult to solve because the places we need to put those sensors are too far away from everything. And the problem I'm talking about, of course, is climate change. Mm-hmm. So, it's the brilliant Brett Victor Worry Dream, known for amazing experimentation in new styles of programming interfaces. And if you're not following what's going on I think it's called Dynamic Land. It's a really bad name for unbelievably brilliant technology of doing real-world programming using physical objects. Absolutely stunning what they're doing.
Wow.
I can't believe I forgot the name right now. How embarrassing. But he's got a great blog post called What Can We as Technologists Do About Climate Change? This is obviously the number one most important factor of our times as far as changes to the physical world, which are going to impact the world we live in. And what we as technologists can do about that, he's got a list of different technologies, whether that's better visualization and scientific analysis technology. That one's a little far away from me just because I'm not a scientist. I know a few, and I have no peer-reviewed papers. But I am a technologist, so one of the areas in particular is we need better technologies for controlling the physical world, for monitoring and controlling the physical world, as a part of our broad response to these changing environmental conditions. So what we're going to need to be able to do that is we're going to need to be able to, first of all, repurpose a lot of existing technology we have right now, right? There's a lot of chips already out there. We need to be able to recycle them. So that's one reason, for example, I've spent a lot of time working on TinyGo's AVR, Arduino capabilities. It's a very old architecture. It's really lacking in a lot of capabilities. But there's a lot of chips out there and a lot of boards, and they can be repurposed to do useful things that we're going to need to be able to do. So every sufficiently advanced technology starts out in the form of a toy. That's paraphrasing Chris Dixon, I think. But you start with toy ideas and playing with concepts. That way when you say I'm playing with it, you're not on the hook to actually do anything useful or even working, right? Like, I'm playing with WebAssembly. That means I'm not actually responsible for writing a working WebAssembly program. I'm just checking it out.
Yeah.
So no pressure. I'm free to learn and experiment without a requirement for any particular thing. At some point, I either put it aside and play with something else, or I kind of cross the chasm over from, are you still playing with it? Yeah, I'm using it now for X, where X is some useful task. This is where it all begins. And so, the toys are our first step to acclimating our minds as developers, going back to something Matt said. You're a web developer, you know a lot about web technology, You've thought a lot about it. Now you can apply some of those same principles towards edge computing and solving some of those problems. That's where the pool of humans that we're going to need to work on these problems are going to come from. There's no mysterious pool of roboticists that are going to spring out somehow fully formed, ready to go. We have to work with the humans we have here right now. We're it. There is no rescue coming. We are the rescue party.
And that's why I love the Gopherbot project, actually, because it gives everyone that. It gives you the thing to play with. It's everything you need. So I recommend people head over to gopherbot.com. So Ron, are you going to be at GopherCon?
Yes, actually, this year's GopherCon is going to be the biggest and best GopherCon ever. I know. It's in San Diego, which is hot. Southern California, where my family lives. So you might meet my parents. But more importantly, on Community Day, so GopherCon is a 4-day conference. First day is the tutorial and workshops. There's some really great ones happening. Mark Bates is doing a cool one on testing. Matt, are you doing one?
No, I'm going to be speaking, though.
I know Johnny is doing one. Yeah, there's going to be a bunch of Bill Kennedy's doing one. There's really great training. So then the second and third days of the conference are all of the talks, and those are going to be full of great learning and great interactions. But the last day of the conference is by far the best one. And if you don't make plans to stay for the last day, you're messing up. It's the Community Day. And every year we've done a hardware hack session. We call it GoBots and Other Flying Objects. And every year it gets bigger. Literally, physically, it takes up more and more space. They give us like a double wide amount of area. We have a drone zone where you can do Go-powered flying of drones. Last year we did Gopher Car, which was based on Donkey Car, which is a self-driving car using Raspberry Pis that was Go-powered using cameras and combining GoBot and GoCV. And we had a bunch of kits for doing sensor hacking and things supplied by different sponsors. So you don't have to bring any hardware of your own. We bring lots and lots of it. We have tons of giveaways, activities, fun. So it is absolutely incredibly great. And if you don't go, you're totally blowing it. Because not only will you learn something, but you'll have fun, more important.
This episode is brought to you by our friends at Rollbar. Move fast and fix things like we do here at Changelog. Check them out at rollbar.com/changelog. Resolve your errors in minutes and deploy with confidence. Catch your errors in your software before your users do. And if you're not using Rollbar yet or you haven't tried it yet, they want to give you $100 to donate to open source via Open Collective. And all you got to do is go to rollbar.com/changelog, sign up, integrate Rollbar into your app, and once you do that, they'll give you $100 to donate to open source. Once again, rollbar.com/changelog.
Ron, and something that occurred to me as well, when we talk about TinyGo on either in the web browser or wherever it is running on these these microcontrollers, how does garbage collection work? Because that's something that's part of what makes these binaries big and fat, is the runtime that's going on. And so how does TinyGo deal with garbage collection? Just a technical question that I wondered about.
So TinyGo has relatively limited support right now for garbage collection. On some of the architectures, like on the ARM Cortex microcontrollers, there is a very simple mark and sweep style garbage collection that's implemented. On AVR microcontrollers like the Arduino, there's no garbage collection implemented at all. Part of that are the limitation of the 8-bit processor, and also that I believe that the data and the instructions are not actually in the same memory space or something like that. There's some weird things about the AVR architecture I probably have wrong, but it's not currently implemented there yet. So it turns out, though, you can write useful code without garbage collection. One way is to use structs that have members that include the memory that you're going to need. Another one is to use global variables that exist we have some implementations of some things like a ring buffer that are to a large extent what you will often need for doing, various kinds of I/O. So you can definitely write useful code without garbage collection. That said, it is an objective of TinyGo to be able to support garbage collection and several different kinds of garbage collection algorithms and backends. One thing that we want to do is be able to plug TinyGo in so that it can use a real-time operating system's memory allocators and deallocators. That way, if you're going to run some other code, some C code that you want to call from your Go code, and by the way, on that, so one big advantage of compiling and linking using LLVM is we don't have all of the things that you would need with CGo in the normal, main Go implementation. They're just function pointers to us ultimately. So we're able to make much, much faster calls between Go and C because it's all just binary code here in TinyGo at the end.
That's really cool.
And the current version of TinyGo, we spent a lot of time simplifying the installation process and removing extra dependencies that you need to install. We didn't get rid of all of them. If you want to compile for these microcontrollers that are based on ARM Cortex, you still need the Clang compiler. But the next version of TinyGo will eliminate that. So you'll actually be able to compile your Go and your C code all using just the TinyGo compiler. So that will take us into a really exciting space where there's existing C code that runs on these different microcontrollers that you need. Some of it are SDKs for things like the real-time operating systems. That way we can use Zephyr and FreeRTOS and Riot OS and some of the others. Another is there's closed source code that has open APIs, but the implementation are closed, like the Bluetooth Low Energy implementation on all the Nordic semiconductors, like the BBC Microbit is a really cool little board. All the kids in the UK got those boards a few years ago, and there's been a bunch of them. Matt, you probably have one that you nicked off some kid in the neighborhood.
No, I got it through legitimate means.
Yes, I'm sure you did, sir. I'm sure you did. But the BBC Microbit has a built-in Nordic Semiconductor NRF51 chip, which includes a whole Bluetooth Low Energy stack if you can call into these closed source libraries. So, one of our big objectives is we want to be able to combine all of this code together, execute it very small, very fast, still using Go's concurrency, because we're able to run Go routines right on these microcontrollers, which is in itself kind of amazing. I mean, that blinky LED on the end of a spring is actually in its own Go routine in our Gopherbot demo code.
Oh, man, that's amazing. So it supports Go routines?
Yes. Now, there are a couple of differences and limitations. The TinyGo implementation of Go routine uses the Clang coroutines, which are another concurrency execution module that is able to do much of what we expect from Go routines. We do have an implementation of channels already. However, there are some limitations in that. The biggest one is which we do not yet have the select statement implemented. So once select is implemented, then channels are going to become a lot more useful, but you can use them right now. And there's also a branch that's a work in progress with some implementations of sync atomic. That way you can do some synchronization between some of these Go routines that may require it.
That's brilliant. And if there are people listening that want to get involved in this and maybe they like the idea of implementing channels or select capabilities somehow, what sort of help are you looking for and how can they get involved?
Well, we're looking for tiny gophers at every experience level, including and especially no real experience. If you've never tried any of this before, we want you because you are the perfect person to give it a try and help us smooth on that onboarding process, make it a lot easier for people to get started trying to actually make things with TinyGo, whatever those happen to be. your own cool devices and gadgets, games and toys, or, even for that matter, industrial type systems, whatever those happen to be. The other part of it is contributing to TinyGo itself. So we've spent a fair amount of time working on improving the process for people who want to install TinyGo from source code directly. We have some make tasks. That way you can install the latest LLVM directly from source. And it makes it a lot easier for people who want to delve in and try to add something to TinyGo. One of the most interesting is Carolyn Van Sick, who's been working on adding TinyGo test. That way we can actually use TinyGo to execute the tests themselves. That's going to be really, really useful. And learning about the internals of how Go does its implementation of Go test is also terribly interesting.
I bet.
So there's really no better way to learn how these things work than to try to enlist them into building something else that uses the same tools. That's for sure.
Yeah, brilliant.
Oh, yes, I'd like to also mention, for people who want to really understand some of the low-level stuff, IK published a great blog post yesterday at ikvl.nl. It's called LLVM from a Go perspective, and it talks about taking some very, very simple examples in Go code and how those translate first to Go SSA form and then also to LLVM IR form. So it's a great way to get some ideas about how, whether you're interested in helping contribute to TinyGo or you just want to understand a little bit more about how modern compilers work under the hood, great blog post, really. I've been reading it repeatedly, just like, aha, that's how that worked.
It'd be a good talk as well.
Everybody thinks I do all the hard work, and I think everybody else does all the hard work. I believe that's called a virtuous circle. And that's really the power of open source is, if we all collaborate together, whether that's directly by, here's some code, indirectly by, I tried it and it didn't work, and here's what didn't work. There was a great talk, I can't remember who gave it a few years ago. I saw it in London from a woman who was involved in doing some IoT related stuff. I can't think of who it was right now, but she had a really great point about people who were first getting started and wiring. So when you're doing electrical wiring, it's very common that the red wire is the positive and the black wire is the negative, right?
Okay.
But if you don't know that, you may not realize that the colors matter, right? Like that's kind of a custom. Nobody explains that to you. This is really key information. So when you're first getting started, you don't have any key information. You don't even know what information is key. So you're really helping us out just by, if you struggle trying to get something to happen, you're not alone, and we want to know about it so that we can help everybody else who's going to run into that problem, because maybe we know too much. We already have it all installed. Maybe there's an installation problem we don't know about.
Yeah, actually, that's a good point. So whether you've got any experience or not, or if you even feel like you're ready to contribute, have a look, because you might be surprised. I think that's great advice, Ron. And it's nice that projects like TinyGo and Gopherbot, but TinyGo, it's nice that the contributors and the maintainers are welcoming of other people as well. That's really important. So that's a great thing for the community. And I think we talked a bit on a previous show about in interviews, one of the bits of advice I always give to people is if you don't have anything else that you can talk about in an interview, get involved in some open source stuff. And this TinyGo is a great example because it crosses over into the real world as well, which is always just an interesting and an exciting thing to talk about. So that's just my advice for any kind of ultra junior or people that are just getting into it.
Well, that's absolutely true. Plus, you need an edge, okay? That edge could be that you made an LED blink on some hardware. The uninitiated are quickly impressed by your newfound skills. You are impressed by your newfound skills.
Yeah, I'd be impressed by that.
Right? And that can give you the confidence to think, oh, I can go learn these other things, because it turns out that, most of the Internet of Things and robotics and drones is just turning things on and off at the right times. And that's it. If you do that, you're golden.
They make it sound so easy, Ron.
Turn off the laser right before it, shoots you in the face.
Yeah.
That's my motto.
By the way, I knew that red wire was positive thing because of all the James Bond films. They make that very clear, so hopefully we're all right.
Remember that movie, The Abyss? They're under the ocean. Like, all he's got is one of those glow light sticks, and he can't tell what the colors of the wires are to cut the right one.
Oh, nightmare.
That's the story of my life right there, man. Story of my life. Which wire do I cut? I don't know. Cut them all.
Yeah. I always think that when they're defusing a bomb, it's like, oh, I'm like, software basically never works. So it's probably not going to work anyway. Just mess around with it. It'll be fine. It's not going to go off. That's my advice, but I don't work in bomb disposal.
Yes, well, it's definitely good to try it with an LED before you connect the cutting laser.
Yeah. Yeah, exactly.
Good piece of advice I got once.
Very good.
Just to be sure. Just to be sure.
Will the LED on the top of the spring ever turn into a laser, do you think? Or will it be the eyes?
I think that it's very possible for someone to do that, but I may or may not actually do that myself because it will be pointed straight up and it'll probably hit someone in the eye. And I will be that someone.
Yeah. But that's a good way to go out, isn't it?
Keep your lasers pointed down. That's a...
Ron, you're definitely going to die by your own creations somehow. There's no doubt about that in my mind.
Well, there's two kinds of people. The people that build the robot and the people that fear the robot. So you kind of have to decide which side are you on.
Yeah.
But, would you rather the robot just instantly disintegrate you? Or would you rather it hesitate for a few microseconds while its facial recognition identifies you as one of its creators and then disintegrates you? I prefer the latter.
Yeah, so we do want Machine Box.
Exactly. Exactly. You're going to need that at some point.
Yeah. Have you got any advice for people that are building robots that could eventually take over the world? Because you're doing that, really, aren't you?
Well, the world's a very big place, and there's plenty of room for robot empires. Mars right now is the only planet in our solar system inhabited entirely by robots.
Yeah.
Which is why it's such a peaceful and good place. Well, the most important thing, I think, there's two parts. The first one is many people know very little about any of these things. So do not be intimidated to experiment and explore. And you don't need the latest and greatest, cool hardware to do this. Literally, like leftover Arduinos that you can come up on anywhere. If you have hardware sitting in a drawer somewhere, get it out and give it to someone before it turns into hazardous waste, right? So that they can learn. But don't be afraid to experiment a bit because it's, again, playful, cool way to learn. But then the other side is, let's not forget about why we're doing these things, right? We can build a world of killer robots, or we can build a world of helpful robots. Really, that's up to us. Right now, calling it artificial intelligence is a bit of a misnomer. It's a bit more like intelligent applications. Programs that have some small amount of intelligence built in very specific areas, but that don't have any general intelligence, nor is there any indication we're going to actually get general intelligence anytime soon. And, if you read people like Roger Penrose, we will never have that. Does that mean it's not useful? It's still very useful, but we must be very careful because the biases that we bring as humans into the equations can have a direct impact in the physical world. The immediacy of that is something that we really have to think about. Should we build it? We need to think about that before we build it, not after we build it. The same technologies that can do good can also do harm, sometimes unintentionally, sometimes intentionally when usurped by, bad actors. So we really need to think about these systems very, very carefully when we're deploying them into the real world because they have consequences that we don't expect. And also, physical systems are going to be installed for a long time further than originally planned. I mean, anyone who's ever worked in, a factory or a retail store, they install something and it's there for years past its expiration date. Part of that is because, they're too cheap to replace it. Others because they forget it's even installed. So we really need to think about this when we're putting devices out into the edges of the world. At least in a server room, we can go around rack to rack and say, oh, what's this doing? What's that doing? these devices that are out in the physical world, we may not even know where they actually are. We've seen a number of cases where seemingly innocuous devices were taken over to do, very bad things, like the Mirai botnet. So it's important for us to apply very serious architectural and industrial strength thinking to to distributed devices before we put them out there, not after, where we're like, oh, there's no way to update these. Oh, well, too bad. No, that's not an acceptable answer. It's really about ethics in device-oriented development.
Yeah, but it's real. It is real. Well, on that bombshell, all that's left for me to say is that's our show. Thank you so much to Dead Program, aka Ron Evans, for educating us about TinyGo and sharing his passion about Gopherbot.com. Definitely check that project out. And don't forget about the quiz. If you want to win a Gopherbot kit, including all the bits and pieces you need so you can write TinyGo code and create your own Go plushy robot, then check out the show notes for the quiz, and you just have to share the podcast essentially and send an email to gotime@changelog.com. And that's it. We'll see you next week. Thank you very much.
All right, Go Time is back. It's been so much work behind the scenes, but it's definitely paying off now. And it's so much fun producing this show. We have so many people listening live. Thank you so much for that. We love you. And if you're not yet, hang with us in Gopher Slack. We have a channel called Go Time FM. Look it up. You'll find us. Chat with the community, share stories, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions on every single episode at changelog.com. So head to changelog.com/GoTime, find this episode, and discuss it with the community. And of course, thank you to our sponsors, DigitalOcean, StrongDM, and Rollbar. Huge thanks to Fastly for being our bandwidth partner. Head to fastly.com to learn more. And we move fast and fix things around here at Changelog because of Rollbar. Check them out at rollbar.com/changelog. And we're hosted on Linode cloud servers at linode.com/changelog. Our music is by the one and only Breakmaster Cylinder. And if you want to hear more episodes like this, subscribe to our master feed at changelog.com/master, or go to your podcast app and search for Changelog Master. You'll find it. Subscribe, get all of our shows in one single feed, as well as some extras that only hit the master feed. Thanks for listening. We'll see you soon. Because you've listened all the way to the end of the show, got a little preview here for you of our upcoming podcast called Brain Science. This podcast is for the curious. It explores the inner workings of the human brain to understand behavior change, habit formation, mental health, and the human condition. This show is hosted by myself, Adam Stakoviak, and my good friend Muriel Reese, a doctor in clinical psychology. It's brain science applied, not just how does the brain work, but how do we apply what we know about the brain to better our lives. Here we go.
That applied brain science really stood out to me because I don't want it to just be data. I want you to go, how can this fit? What can I take away? Now, how am I going to change? And that sort of is where you come in more, and even some of the questions I want to ask you, what are some of the most challenging things working in the tech world when it comes to relationships?
Probably the most important one is isolation. More and more the world and companies are being, for good reasons, they're being okay with what they call distributed teams.
Yeah.
And that means that you and I, we work for the same company, but you work from your home office, I work from my home office. I might go into the office a couple times a week if I live local, but even if I live in San Francisco, I'm still probably a remote worker, even though I can hop in an Uber or hop on, the train or whatever and go into the office and be there in a half hour. But why waste the time?
And this is where I would revisit what I want to talk about with resonance. And that whenever we're learning, no matter what thing, it's really helpful when we get feedback that's both immediate and specific. And so when you're by yourself and you don't have any interaction with other people, how can you get any feedback? I mean, you're losing most of the nonverbal communication, and you also don't have all of the voice inflections or facial expression. Have you ever tried to, be sad, feel sad, and smile at the same time? Try it.
It's pretty hard.
Right, because facial expression is exactly what's involved when it comes to empathy, which is relationships. I was reading a research article recently, and it talked about, how couples who are together a really long time end up sort of looking like each other. You ever heard that? Yeah. And so what they've looked at is when we actually empathize with other people, facial expression is really key within that. And so when you empathize with the partner you're with over and over and over again, your face begins to make the same creases and facial expression as it relates to where somebody else is emotionally.
Wow.
Right?
Say it is. So that's creepy.
Well, this is sort of the hotbed when it comes to neuroscience these days, is mirror neurons. And these mirror neurons are what are involved with empathy. And so mirroring, meaning I get another person's emotional world. And so one of the research studies looked at Botox. And what they found is that Botox, because it actually assists in paralyzing facial muscles,
right?
But then you can't contort your face, so you don't get wrinkles. But actually, levels of empathy go down. Right.
Because your physical appearance can't reflect your inner appearance.
You got it. And so when you're working in these remote locations, it might facilitate better work or more focus, and it allows people to be distributed and to capitalize on the talents across the country, right?
Yeah. Wow. So that's like a treasure trove, in my opinion. Talking about in a scientific way, not just like, hey, this is my opinion.
Yeah.
About all the cons of that, because I think what we can do is still have remote work, but do it in more healthy ways. Because I've been self-employed remote worker since 2006. Now I'm a unique animal. I know that. My wife knows that.
Right.
And I'm fine with it. I'm a good human being, but I've got some flaws, and I'm willing to accept and share those to some degree. And I think the problem is we just lack maybe a more purposeful or intentional feedback loop.
Yeah.
Which I think is super important to being able to operate in this world in just good ways. I don't know, healthy ways is probably the best way to use in this show context, is healthy ways.
One of the things that's fundamental, I would say, to being human is change, right? And so sometimes people come in and are really key in our life for a period of time, and then things change. Either we grow or they change in a different direction, and then the relationship changes or that feedback loop gets modified in some way. That isn't always a bad thing. It's just going, my sense of choice actually is a critical component when it comes to feeling good about my life. If I feel like everything is sort of outside of me and I don't have any charge over it, like I didn't choose to work in a more remote location, or I didn't choose to go to school, or I didn't choose this person, then it feels far more oppressive, as opposed to I actually participated in the outcome that I'm actually experiencing. So I then also have more charge over whether or not I want to change it.
I think this feedback loop process that we're talking about here is super common to developers. From people who write code to people who plan and to engineer and to manage and lead. Like, there's no one in the software process that doesn't understand the feedback loop. And the reason why is because in product development, they have this concept of agile. And basically it means you produce something, you put it out there, and you expect the feedback loop to happen in order to gain insights and course correction to then release another version of it that continually and iteratively becomes more and more improved. So this whole process in day-to-day work in software is normal.
Mm-hmm.
And I think it's interesting how it can apply to their lives and people's lives, to take the same importance of a feedback loop, for example, and apply it.
Right. Well, so this is very much how it goes in relationship, which is why there is an importance when it comes to sort of things resonating. You ever walk into a room or an interaction with a couple other people and like something just feels wonky or off? You're like, I can't put my finger on it. But
Definitely been there.
right? Well, and so to be able to identify that in relationships and even go, wow, I'm experiencing this person in my world with the limited interactions that I have with them. It hasn't really resonated with me, and so I don't get good feedback. So now I'm going to be more defensive because I feel as though there's a threat. It doesn't necessarily mean the person is threatening. However, my brain is going to tell me, hey, we need to be more protective.
Yeah.
We need to do some strategies so that you're not fully exposed.
One way I look at scenarios like this, I would say as of late, is because have you ever watched a TV show or a movie where the narration, the storytelling part of it, they expose a character in a certain light, and you may dislike that. They may be a villain or villainess, right?
Sure.
But the moment they turn the story to their backstory and why they are the way they are, or why they're acting the way they're acting,
yes,
you then kind of fall in love with them and you're almost rooting for them.
Right?
I feel like that's the same thing that happens day to day to our lives, is that, there are people who seem villainous or not for us, but we don't understand their backstory and why they are the way they are for us to have and employ that empathy that's required to have this dance, as you say, this iteration of relationship. We just assume they are who they are, and we project, our worst fears onto them, and they become true.
Yes, you got it. This is why in the absence of, a face, I don't really get to engage with people in the same sort of humanness that we are all in. And so you're exactly right. I mean, over and over and over again, because you can identify and go, oh, that's why they're harsh. Or, I recently had an interaction. I had shared with someone that I was a competitive gymnastics coach for a number of years. And so somebody thought that my response to them when they were really struggling was kind of harsh, but they remembered that I had told them I was a coach for so long. And they're like, oh, this is just another side of her coming out.
Right.
And I'm not sure I prefer it, but I get it. And then it switched for their reaction, because then they're like, oh, wait, we're on the same team. She's not trying to oppress me or fight back against me. She actually is helping me, trying to get me to where I want to go.
My wife and I, we've learned this concept of goodwill, right?
Yeah.
I can take your feedback or your criticisms in a different light if I know that you have goodwill for me.
Yep.
Meaning that you're not trying to harm me, that you are for me, not against me. And sometimes change, as we all know, is painful and can be painful. So sometimes the necessary feedback and or criticism that can influence that change can also be painful. But I can accept it differently if I know that she or they or whomever is in the scenario with me has goodwill for me, whereas if you know that they're not for you, then you obviously take it a whole different way. And that's an okay thing. But we often are, in relationship with people that are giving us crucial feedback, and we need to have that kind of that lens. Like, it was significant in our marriage to understand, hey, I know there are times when you give me feedback, I am not happy about it, but I know you have goodwill for me. So therefore I calm down, I listen, I take that in and I process it, whatever, but I take it in a different way because I know that she's for me and not against me.
Yep. One of the key things when it comes to change is a sense of openness, and even relationally, of going, I need to be able to see how somebody else responds or how they're feeling as based on their perspective of what they're going through, and not just my perspective of their perspective. And so this goodwill is I believe that we're on the same side and that you're not trying to make it harder for me. But so I can understand if I were sitting where you were sitting, had the background that you had, why you would have taken it in that way. And then I can provide an opportunity to clarify or create more connection, even when it doesn't feel good. And I honestly think this is so much of what's missing in people's relationships if I look at relational interactions through the notion of conditioning, wherein I get a sort of hit of dopamine, feel good feelings because I went to a person, I had a conversation that didn't necessarily feel good, but there was openness on both parties to hear one another's perspective, that it actually then reinforces like, oh, when I go and I have this exchange with people, I feel better. So now I'm going to go and engage with other people and get the feedback, even if I might not like the feedback, because now I'm buffered and I'm not alone in this and somebody else sees my world.
That's a preview of Brain Science. If you love where we're going with this, send us an email to get on the list to be notified the very moment this show gets released. Email us at editors@changelog.com. In the subject line, put in all caps, Brain Science with a couple bangs if you're really excited. You can also subscribe to our master feed to get all of our shows in one single feed. Head to changelog.com/master or search in your podcast app for Changelog Master. You'll find it. Subscribe, get all of our shows, and even those that only hit the master feed. Again, changelog.com/master.